Hello, everyone. I'm Steve Nunn, the President and CEO of the Open Group, and I'm delighted to welcome you all today to this special event marking a significant milestone. Today, we are proud to announce the release of the OSDU Data Platform Mercury release. So what's it all about? Well, energy companies don't just face the economic challenges that all industries are facing as a result of the current pandemic, but they must also manage the transition over the coming months, years, and decades to a lower carbon environment. Key to the strategy of most companies is embracing the revolutionary transformation technologies taking us forward in the data-driven era. The first foundational step is the development of a common data platform and architectural design which underpins how the industry works with its data. Data that is easy to find, easy to use, and easy to trust will help open doors to larger opportunities to improve the way we work. By bringing data together in one location, the OSDU Data Platform will reduce costs, remove data silos across the industry, and enable innovation. The OSDU Data Platform Mercury release represents an important achievement by the Open Group OSDU Forum in a very short space of time. Not established until 2018, the OSDU Forum has accumulated nearly 200 member organizations who are collaborating together to accelerate innovation and reduce costs in the energy sector. With a standard data platform, energy companies will be able to drive innovation by integrating digital technologies and utilizing open standards for better decision-making. Looking ahead, this will be imperative to meet the world's increasing energy demands while reducing emissions. So this is indeed a significant day. Thank you for joining us. And without further ado, I'm going to hand over now to Philip Yong, the chair of the Open Group OSDU Forum, to tell you more about this exciting release.
Good morning, good afternoon. Welcome to the Mercury Global launch event. Today, after the welcome and introductions, we would invite Michael Steele, Vice President of Upstream Digital and R&D from ExxonMobil, to deliver the keynote. And after the keynote, Raj Kannan will discuss the scope and content of the Mercury release. Then we will show 7 video demonstrations of applications and services that are available on the OSDU Data Platform. The Mercury is only the beginning. We would like to share with you today the goal of making the OSDU Data Platform the data universe of the future energy system. Johan Kraber will present the Open Energy Data Platform. We will have a Q&A sessions before we close the meetings. It is a perfect time now to reflect upon our journey that started in March 2018, when we made initial contacts with other operators. 8 operators agreed in June of 2018 to collaborate under the Open Group OSDU Forum. The founding operators joined OSDU Forum in August 2018. On August 22nd, 2018, Shell contributed its internal subsurface data universe, SDU, to the forum. The founding operator were aligned with the OSDU vision, reference architectures, and the ways of working in September and October of 2018. In August of 2019, 1 year after inception of the forum, we completed the OSDU R0 release on both Azure and AWS. On August 22nd, 2019, 1 year after Shell made the contributions, Schlumberger contributed its open data ecosystem to the OSDU Forum. This certainly provided additional momentum to the forum. In December 2019, we completed OSDU R1 releases on both Azure and AWS. In May 2020, we released OSDU R2 on Azure, AWS, GCP, and IBM. Here we are today, March 24, 2021. We launched OSDU R3 Mercury release on Azure, AWS, GCP, and IBM. So far, we have made 4 major releases, and we're happy to have our first production release today. The OSDU Data Platform can make a difference. The forums believe that OSDU Data Platform can make a difference in shaping the strategic priorities of our industry, namely digital transformation and energy transitions. The Mercury release can be used as the central repository of all data and supports the scaling up of digital advanced analytics program that translate data into business value. We all have had sophisticated data systems for years, but we all struggle to connect disparate systems and data in an easily scalable way. The Mercury release gives the industry the beginning of an open and standard energy data system through which we can capture value from improved efficiency and uncover new growth opportunities. For the past many decades, our industry has been successful in running our business with an application-centric environment, as described in the left-hand side of the pictures. However, this application-centric environment cannot be used to underpin the new data-centric applications. Therefore, the vision of the OSDU is putting data at the center of the energy industry. This involves a number of steps. Step number 1 is to separate the data from the applications. The step number 2 is to remove the data silos and use the standard data schema for all data. Step 3 is to implement metadata to enable search and discovery of data across all data domains. Step number 4, implement a set of application programming interfaces to allow applications to interact with the data. Additionally, that the platform needs to be secured and managed. The core data platform with the security and operational utility becomes the data ecosystem that supports rapid application development. This has been a great collaboration. We have exactly 193 member companies, and the forum is still growing. Throughout the Mercury development period, we have anywhere between 133 to 212 active software developers. And beyond software development, we have anywhere between 57 to 107 active staff on various R3 projects like testing, data loading, operating procedures, documentations, marketing site, etc. We also have 150 staff on various technical subcommittees and projects. We also have 18 plus staff from the open group to help us on legal, certification, contracting, marketing, branding, recruiting, onboarding of new members, forum support, and many other activities. The forum span over 1 million person minutes on WebEx meeting in 2020. It amounts to 2,372 effort days. So this is a great collaboration during COVID-19. So hope that you would enjoy today's lunch. I would like to invite Vice President of ExxonMobil, Michael Steele, to deliver the keynote for today. Michael.
Thank you all. Good morning, good afternoon, good evening, wherever you are in the world. The OSDU community gathers here today to celebrate a major milestone. A milestone that begins to enable acceleration of innovation in our industry. It has taken tremendous collaboration, leadership, and hard work from many people in the community to get us to this point. I'm Michael Deal from ExxonMobil, and I'm proud that we are one of the 8 founding members of the OSDU Forum. I appreciate the opportunity to share a few perspectives with you at this exciting moment. Research and innovation are my passions. In my role as Vice President of Research, Technology, and Digital Development, I am energized by the network of collaborations we have with leading universities and institutions around the world. These partnerships are an essential part of our commitment to find affordable and scalable solutions to meet global energy demand, while also minimizing the environmental impacts of energy use, including the risks of climate change. ExxonMobil has collaborations with more than 80 universities and energy centers around the world, advancing the science and technology needed to drive innovation in the work we do every day. In the same manner, I'm also excited about leveraging open source models and learnings to promote uptake of data standards for the oil and gas industry. These shared standards will not only help drive efficiencies, but perhaps more importantly, they will help drive the acceleration of innovation at a scale in our business processes. ExxonMobil's support of the open source software and of industry standards is not new. For example, we are one of the 5 founding companies for the predecessor of Energistics in 1990. The same companies are part of the founding members that formed the OSDU Forum in 2018. A decade ago, back in 2011, ExxonMobil released an open source developer toolkit to help oil and gas companies adopt Energistics data standards, such as WITS-ML, a standard for transmitting well site data from the rig to different stakeholders in the industry, PROD-ML, and ResQ-ML. Standards such as these across the energy industry lower the learning curve while reducing custom development efforts. The industry is now going through a large-scale digital transformation. It is ever more important that we define, adopt, and evolve data standards together to accelerate digital innovation at scale. The OSDU Forum has a strong vision, a compelling vision for the industry. The forum promotes and utilizes technology standards, new digital technologies, and best business practices to address both the business and the technical issues related to subsurface data. The forum was modeled on the success of the Open Group's Open Process Automation Forum, which developed an open architecture and open standardization software interfaces for the continuous process control systems. These systems are heavily used for downstream oil and gas refining, as well as related chemical processing. The OSDU Data Platform supports an open, standards-based energy ecosystem, which should accelerate innovation while leveling the playing field for customers, vendors, suppliers, and users. This will deliver flexibility to customers, such as ExxonMobil, to select the best of breed services for any specific need, and then further differentiate themselves by more easily developing proprietary in-house applications on top of the OSDU Data Platform. In 2 short years, the forum has grown from 8 founding members to nearly 200 active members, representing a broad swath of companies across the energy ecosystem. The forum members work collaboratively with other standard bodies, such as the Energistics Consortium, the Professional Petroleum Data Management Association, and the International Association of Oil and Gas Producers. These major industry standards organizations have signed memorandums of understanding with the Open Group to participate in the OSDU Forum. The Mercury release, which we are celebrating today, is the first production release that is intended for use by the energy suppliers to enable efficient analysis of subsurface data and to make informed exploration and development decisions. I'm excited to share that ExxonMobil is ramping up our preparation efforts to adopt the Mercury release. This release will allow us to experiment and implement OSDU while maintaining our commitment to the continued success and evolution of the OSDU Forum. The industry has come a long way, and we are in a time of significant change. The challenges facing our industry perhaps have never been greater. We need energy innovation tied to what society demands: affordable, scalable, low-emission energy. And the root of that is going to be based in new technical solutions and innovation. I'm confident these new solutions will require collaboration to a degree that we have not seen previously in our industry. The network of interdisciplinary and inter-industry collaborators of the OSDU Forum have delivered a significant milestone today. It is a testament to the power of putting aside company boundaries in a space where collaboration is essential. To make sure we achieve the OSDU vision, it is ever more crucial that all member companies adopt OSDU standards and resist the urge to make individual customizations. I understand we need to continuously evolve and grow the OSDU standards to enable new technologies. We must do this with the velocity that many software developers want and require. However, we must do it in a considered, managed approach that is based on prioritization of near-term focus areas by our community. Let us evolve and grow OSDU together as a community. I hired into Exxon's upstream research organization over 20 years ago. I remember as a young researcher working on anisotropic migration algorithms, struggling with seismic data formats, data consistency, data translations. You get the picture. I'm excited for a new future where the next generation, the brightest minds across our industry, can focus on the most impactful technology problems to answer the critical business decisions facing our organizations without the need to fight with translations between many different conflicting data standards and formats. A lot has changed in 24 years, and today's Mercury release marks another milestone, one that reminds me how far we've come. Back when I began my career, I thought my lab was my entire world. Now I know the world is my lab. Thank you for your time and your contributions to this important milestone.
Thank you. With that, we'd like to ask Raj Cannon of Schlumberger to present the scope and the content of the Mercury release.
Good. Thank you, Philip. Good morning, good afternoon, good evening, everyone. Thanks for joining the launch. It was a great talk from Michael to introduce us. And what I wanted to do today was to go through some of the key elements of the Mercury release. And I want to start off by setting some context here. So this is just a recap of what Philip was saying, but more from a software perspective. So you can see the timeline view, but also the key things to note here, or from a software perspective, there were two main code contributions that we've integrated by the time it came into R2 and then leading up to R3, which is what the Mercury release is. The other one that you should also pay attention to is the implementation. So the original implementations were sort of standalone implementations that were done on AWS on the SDU side of things, and on Google on the open data ecosystem side of things. And what we've consciously done is to make sure that the same code, the same behavior is available on multiple cloud platforms. And with Mercury, we are proud to announce that we have the capabilities available to you, be it on AWS or Microsoft Azure or the Google Cloud Platform or the IBM stack. For those of you who may be looking at, in-country and other deployments. So if we get into sort of the platform scope, we would like to group this into these four categories. And maybe taking a step back and leaning on some of the points that Michael was talking about, if you look at what companies are trying to do with respect to efficiency and digital transformation, this requires us to glean insights from data, right? And data insights require us to overcome data fragmentation, data integration, data access challenges. And all of this means that we should be benefiting from the volumes of data that we have and the fidelity of the data that is there in the different sources. And what all of this means is we need to rethink how we store, ingest, process, and glean those insights from the data without losing the fidelity in the process. And this means a traditional database, relational model type of an approach would just not work. So what we tried to do here is to take a modern cloud-based approach, a NoSQL type implementation, if you will. We looked at how we can leverage things like Exchange standards. Michael was talking about, REST-ML and TrodML and so on. So, Exchange standards like Energistics, usage rules like PPDM, and these have been really great stepping stones to advances into the new space with respect to how we can now ingest the data, access the data, exchange the data, and so on. And what we tried to do with the release is really to improve this, take it to the next step with respect to embracing the open source. So beyond just the standards and the rules, we can now move on to a physical software realization that embodies these standards into interfaces, into behavior, and based on a set of cloud-native technologies that prevent fidelity loss and is scalable to the different sources and the types that we need to handle. And when we talk about that, of course, when we say cloud, we need to be very cognizant of the security and the compliance aspects of data when we are in the cloud space. So as we work towards a extensible microservices-based architecture, we took information security to heart. This is one of the subcommittees that were giving us guidance, both in terms of the software development and delivery side of things, but also more importantly in the overall deployment and the operational aspects of cybersecurity for the platform. We are looking at high performance computing for future capability around running this in on-premise and other environments where public cloud access may not be reachable. So having said that, quite a few of you may have seen this slide before. This has been circulated quite widely in the OSDU Forum. What I wanted to touch upon here is when we took those concepts that we talked about in the previous slide, we said, hey, look, for years we've been struggling at the data layer, right? We've been looking at different formats, different storages, different APIs, different integration techniques, etc. And effectively what's happening is, as an industry, we are spending a lot of time in sort of the data platform layer rather than the application or workflow or the insights layer, if you will. And what OSDU has really done is it's effectively said, hey, the data platform isn't really a differentiator. It's a necessary enabler, but not necessarily a differentiator. We need to climb our innovation and our values up the chain into the applications and the workflow space. So what this allowed us to do, and Philip gave you the statistics in terms of number of companies and number of contributors, and I'll touch upon that towards the end of my presentation as well, is aligning on this open source allowed us, whether these are cloud service providers, independent software vendors, systems integrators, operators, to all come together and collaborate and deliver a software realization of these requirements. And that's what is shown in the dark green space, the collaboration space, versus the innovation and the commercial or the competing space, which is shown in gray above. So if we drill one more level down into the software architecture, one of the skeptical questions that may be coming up in your head is, anytime we talk about standards, there is an issue of velocity, there is an issue of agility. So what we tried to do here is to come up with an architecture that tries to balance the standards and the governance while allowing for emergent use cases in a much more elegant manner. So that's what you see with the domain-specific services in the layer in the middle, what is shown as DDMS, and we will come back and explain what a DDMS or a domain data management service is. And that is closely connected into the platform's core code, which ensures that no matter which domain you are dealing with, there is a consistent set of behavior, and how we deal with identity or discovery or security or compliance is all done in a very consistent manner across the whole platform. I mentioned before that the initial implementations were tied to specific cloud providers like AWS or GCP. In the open source space, what we've also done is call out the service provider interface. So all the behavior of the platform is done in the common code that you see in the blue boxes, be it the domain-specific services or the domain-agnostic core code services. But the service provider interface allows us to connect that common behavior into the cloud provider-specific implementation, be it Amazon or Azure or IBM or Google, or other cloud provider implementations or other backend infrastructure implementations in the future. So if we go down to the next slide here, so now let's drill one more level into that architecture. So we understand the scope of the OSDU platform. We understand what is common code versus the service provider interface. Now let's take a different perspective at it and look at it from a life cycle of data or a flow of data perspective. So at the heart of it, the system supports an ingest, store, enrich, deliver approach. And this is, like I've mentioned before, different than a traditional SQL or a database approach where there is one data model and you bring the data into that data model into that format, right? So what this allows us to do is to take a more modern NoSQL type of approach where you have flexibility in schemas that allows you to connect it to the different sources, the different domains, the different data types that you see on the far left. So the load and ingest is a way to bring data into the system with the lowest amount of friction, the highest amount of fidelity. And the discovery is what allows the different workflows on the top and the user personas that are associated with it to get access to the data, no matter what is the source from which the data was ingested. And of course, to be able to do it, the question then comes, how do we deal with data that is coming in from different formats, different data qualities, and so on? And that's where the enrichment phase comes in, where we can process, we can improve the data into a form that is ideally suited for the consumption and the delivery workflows. And like I mentioned before, because this is running in the cloud space, governance is very important, security is very important, and as an operational system, we need to think about business continuities, we need to think about reliability and availability characteristics of the system. So this is how we envision the overall architecture of the system. You load and ingest, you process and enrich, and then you deliver and you consume the information. What we did with the R2 release that was made available last year is we provided aspects around governance. The ingestion was quite basic using some Python scripts, and we focused on the key problem that Philip was talking about earlier, which is the fragmentation of the data, the lack of awareness of information across all of these sources, by providing a consistent mechanism to discover and deliver data to the applications in a scalable and secure manner. And what we are now doing with R3 and Mercury is really stepping it up to the next level and saying, okay, let's look at the other pieces of the data lifecycle and make sure we can improve the capabilities of the software on those three angles. So I grouped them into three different categories. So on the ingest side of things, we have now created a workflow service that is allowing us to build new parsers, new loading sequences, new validation steps, and plug it into the framework in a very easy manner. And out of the box, we are delivering ingestions for loading different types of data by providing it a simple manifest that describes the data that you're bringing in. A lot of the sources support, CSV exports, so we have a CSV ingestion. We are also working on conversions on optimization of seismic data, so we can take, SegWi data and then bring that into optimal formats within the data platform. And to do all of this, we need to realize that there is different data sources, there is different data types. So we need to handle the schemas of those definitions properly. And of course, OSDU provides a standard schema out of the box. And because the data is coming in from different sources, they will also have different frames of references. So we beefed up the platform core to handle these nuances elegantly. And we also improved the extensibility of the platform to provide services around registration and notification of new domains. So we are not constantly breaking or impacting the platform core when we expand the platform into other domains past Mercury. And talking about domains, in Mercury, we are releasing two domain-specific services. One is for the wellbore data, and the other one is for the seismic data. A lot of you are using formats today, such as VDS and ZGY. So those formats are also now available in an open source form, and they are integrated with the seismic DMS. So you can access these popular formats in a more scalable manner using the seismic domain management services in the Mercury platform. So what I will do next is sort of jump into each one of these three aspects, the core, the ingestion, and the domain services, and give you a little taste for each one of those aspects. So on the core enhancements, I mentioned that it is very easy to add new domains and sources and data types. This is facilitated by a new service that we are introducing in Mercury called the schema service. So effectively, you describe the data and you bring in the data that complies with this. And of course, from an interoperability perspective, we need to think about how we can leverage the standards. So that's where a lot of the standard inputs have gone in to define a interoperability, a discovery schema for OSDU, if you will. And those are the R3 OSDU schemas that you see on the right side, be it reference data, master data, or interpretation work product components, or the exports that may be coming in from different sources like applications, right? So data sets, files, and file collections. The other part of extensibility is really looking at it from a security perspective. As we expand the system, we need to make sure that the new domains that come in, the new applications that come in, the new cloud provider backends that we may deploy doesn't impact our security posture negatively. So there are a few things that we've done here. One is we've introduced a policy-based agent through which you can define your data authorizations or entitlements and any legal or compliance obligations that you want to enforce on the system. So a basic version of that is being made available in the Mercury release, and a more full-fledged version will come right on the heels of the release itself. We also introduced a concept called a data partition. So whether you are working with your JV partners, whether you are dealing with vendor data versus your own owned data, or for those of you who may be developing applications on top of it, be it operators with your differentiating IP or ISVs, what this allows you to do is to take the classic DevOps approach and have the dev, test, prod environments without having to redeploy a whole OSDU every time to support these different environments. And of course, from a loose coupling and easy integration perspective, there is a registry service and a notification service. We talked about bringing data from different sources. And in that case, we also need to think about frame of references. So units, coordinate reference systems, elevation references, and so on and so forth. So as a first step in Mercury, we are taking two of these frame of reference concerns, units and coordinate reference systems. And we provide both a catalog service and a conversion service that handles the data that may be coming in different frames of references compared to your consumption frame of reference. The spatial search component is also improved in the Mercury release and takes care of some of these coordinate nuances that we need to be aware of. So that is really what we're doing on the core of the platform, if you will. Then if we expand into the load, ingest, enrich phase, I talked about a flexible workflow service. So we chose Apache Airflow. It's an open source project that provides an workflow orchestration capability that is fine-tuned for processing large volumes of data. And therefore, the ingestion workflows are effectively built as a directed acyclic graph, or you will see DAGs in other places. It's just a short form of that. And what that is effectively a way by which you don't have to be limited by the ingesters or the parsers that are coming from the open source. It is very easy for you to define and plug in and enhance the OSDU data platform by bringing in additional ingesters into the platform. And likewise, you're not limited to just ingestion. If you needed to enrich your data, transform the data from the source formats into the OSDU discovery format, you can go ahead and plug in that as well. That said, we are providing out-of-the-box ingesters, like I mentioned before. Then it is from the consumption standpoint of bullet number 3, how do we integrate apps into the OSDU data platform elegantly? So with Mercury, we are improving it from where we were with R2. to allow the applications to run natively on the platform rather than approach it from a delivery service perspective and get an export of the data and go ahead and hydrate it into their own environments. So this is the place where the domain data management services, or DDMS, comes into play. And what it does is it provides a set of optimized APIs that provides not only type-safe access to the data types that are supported in OSDU, but also provides a highly optimized way of accessing the array data or bulk data behind these domains. So what this means is those opinionated APIs can be directly used by an application to access the bits and pieces of data that they need and to produce the results and bring that into the platform, allowing the platform to keep track of the identity, the lineage, or the provenance of the data as it goes through the different domain workflows. And this also becomes a point of extension for the platform, allowing us to bring in other domains using standard domain-driven design principles. So I want to highlight one example here, which is the Wellbore Data Management Service, or Wellbore DDMS. So what it does is, if you look at Wellbore as a domain, you're looking at wells, boreholes, logs, markers, check shots, etc. So obviously, when I'm writing an application, having a generic schema, a self-discovery mechanism doesn't really help with compile time safety and building applications in a manner. So having type-safe APIs for those entities allows the application to reliably bind into it and to have versioned APIs. So when these data models do change over time, to move from version 1 of the APIs to the version 2 of APIs in a reliable manner. It also provides high performance access to the array data. So take the case of logs, for example. In R2, what we were doing is we were delivering a last file or a DLS file as was ingested back to the application at the point of consumption. And it is up to the application to parse and pick up the data by itself. And what the DDMSs now do is they provide APIs for those binary access, and the APIs are optimized for transport of these array data. So we're not translating it into big bulky JSON documents for consumption. And this takes care of both the performance aspect of access, and it also ensures that the applications do not have to just deal with files in and files out. They can operate natively on the data platform itself. So that is how we are really bringing the applications into the OSDU space more together. And just as a recap, there is 3 main categories of improvements that are coming in Mercury. The ability for the platform core to be extensible, to be easily integrated into new domains, a workflow service-based implementation for ingestion and enrichment coming in the future, and an ability for applications to go beyond file-based integration to API and direct integration with the OSDU platform delivered through the domain data management services. And of course, if you're starting off with all of this, there is a set of standards and guides that has been produced by the various subcommittees and working in hand with the PMC team as well. So here are some of the key documents that I wanted to highlight to you, right? So the technical standard gives you the overarching principles for our implementation of OSDU. And towards the left of it, you find the system concept and the reference architecture. And when you get into specific domains and how you want to write your code, we provide both the schema usage guide for the data model centric users, and for the application developers, the application development guide to build applications on top of OSDU. And these guides are available only to the members of the OSDU Forum. So these are under the internal GitLab, if you will. So that is very quickly a rundown of what is the enhancements that are coming into OSDU as part of Mercury, and what are some of the key benefits that you are getting out of the 3 categories of improvements that we talked about. But let's take a step back and acknowledge all the other factors that went into the delivery of Mercury. For those of you who joined early, you saw the collage and the number of contributors that came in. Philip also talked about the number of people that were involved in this. I want to talk a little bit about the specific contributions on the code development side and some of the process and governance aspects that we put in from a PMC standpoint to bring a scale and the right balance between the autonomy and the alignment. So there are 2 main things that we did to bring velocity into the system. The first one is what I call horizon-based capability improvements, and switching us from sort of big bang approaches. A lot of people ask questions like, when is R4 or what is the next big thing that's coming? So effectively what we are now doing is we are moving into a regular cadence of delivery, an agile incremental delivery. So instead of this big mountain of requirements and a big bang release, what you will see is regular predictable milestones, an agile incremental model of delivery past R3. So you may hear M5 is coming in April or M6 is coming in May, rather than an R4 nomenclature, if you will. And likewise, what we also try to do is, as we now start to bring in nearly 200 plus members and potential contributions coming from all of these places, we need to make sure that the governance process is also scalable. So this is what we mean by aligned autonomy. And what that is we want to define the guardrails in terms of architecture and information security from a standards perspective. But how a particular domain or a particular project realizes the design itself, we empower the teams to go ahead and do that. A lot of the projects that are currently underway to be slated past the official Mercury release are doing exactly that, right? So there are work that is going on to connect external data sources or multi-regional replication and so on and so forth, where you will already see the intentional architecture emergent design pattern. And this is a way to make sure that we do not lose track of meritocracy, we do not lose track of velocity while we look for standards to ensure interoperability and consistency of the platform. In terms of contributions, Philip talked about this. So this is just the last 3 months that I'm showing here. Philip is right. If you look at the peaks last year, it was much higher than the 133 active contributors. And these are people that are really working on the code. I'm showing the community GitLab statistics in terms of number of people that are GitLab authors of merge requests. And you can also see it's not just about the people, it's also about how active they're working on these. And just in the span of the last 2.5 months or so, from just before Christmas to now, there's about 2,700 odd commits, and we are constantly reviewing and merging these commits on a daily basis. And each of the commits are not small one-line changes either, right? So there is a lot of velocity that is going on behind the scenes, and I just wanted to use this slide as an opportunity to highlight that for you. So we talked about that from a code standpoint. And to what Philip was saying, we also need to be cognizant that there are between 50 to 107 different active staff on the other R3 activities. So the previous slide was focused on the yellow circle here, the R3 data platform, sort of the code, the configuration, the tests. But there's a whole lot of other things that has to happen to ensure that we can bring this as a professional quality release, something that you can deploy and use in an operational setting. And that's where, whether this is training, test data, marketplace, documentation, additional testing, all of those aspects come into play. From an operations perspective, we need to think about, business continuity measures, deployment measures, cybersecurity measures. So, like I mentioned, there's another 50 to 107 different people that have been working on those aspects as well. Not to forget the people that are on the technical committees, not shown on this slide. And the key achievement of the Mercury release and how it contrasts against the R0 or R1 or R2 is we did a lot of effort in terms of platform validation and what we call pre-shipping assurance. So effectively, we had about 6 different teams of volunteers that were varying the role of a prospective operator and looking at a reference production quality environment that we set up, and made sure that all the R3 components are working together seamlessly, and all the tests are passing, not only from a coding standpoint, but from a deployment perspective, from an operations perspective, from a supportability perspective, that all the documentation is good, and this is something that you guys can start to rely upon. So I want to thank all of the contributors that has worked very closely with us on the PMC to bring OSDU into fruition. And hopefully, in a very short time, I've given you an overview of the data platform scope and a small teaser in terms of what is the Mercury release and what benefit it brings to you. With that, I'll conclude here and pass it on back to John.
Thank you, Raj. Now we have a series of video demonstrations, so I'm going to hand over to Johan so he can make some introductions while we get the video loaded up.
Thank you much, John. Thank you much, Raj, for the excellent overview of where we are today. Now we're going to have 7 short 5-minute videos from 7 different companies who have been working on the platform Raj was talking about. And they've developed about 7 different applications in various spaces. But remember, this morning we showed 6 videos, so in total we're going to show today 13 different companies with 13 different applications out there. So don't assume that this afternoon is the same as this morning. If you want to see this morning, as highlighted by John before, you really have to go look at the recordings which will be available in the next couple of days by John. So the way it works is we have the videos will be 5 minutes. Between each 5 minutes, we have about 30 seconds to introduce the next one, and that we do that 7 times, and thereafter we have our next session. So I want to get my. So let's start with the first one. Blueware. Blueware is quite interesting because Blueware with OpenVDS was one of the first companies contributing to the open source environment. It was in early 2019 where they opened OpenVDS. OpenVDS is very important for the seismic space. It's our prime platform for fast access to the seismic environment. It's part of seismic DDMS, and you heard about DDMS from Rush. So let me hand over now to Blueware for a story around the whole OpenVDS and access to seismic.
In this demonstration, I'm going to show streaming seismic data from OSDU using Blueware Fast. This collaboration was sponsored by AWS, developed by Paravida Solutions in partnership with Blueware. Seismic trace data is stored in the seismic DMS. The Paravida integration talks to the DMS and Fast, a service which exists on the Geoscience workstation. This creates a mapping between the data in VDS and a virtual file which is presented to the application in the format needed for interpretation. When the application reads from the virtual file, data is streamed directly into the application via Blueware Fast. This eliminates disk storage on the local workstation. So let's see how this works in practice. I'm using an EC2 workstation in AWS. This is a typical geoscience workstation. Now note, I haven't created any additional disk because I'll be using streaming versus storing seismic data. When I start the fast service on this workstation, we'll see the mapping to an additional disk. This is where the fast data will be presented to the applications. The Paravida integration works in a browser. It talks to OSDU to get a list of surveys that are available to me. What I'm now going to do is configure a mapping between the OSDU data and a virtual file. And I'm going to create this as a Petrel ZGY file. Note I have the option to create a subvolume, but in this case, I'll create a full volume. And let's see what's happened here. If I go to the fast drive, you'll see the creation of this file here. It's a ZGY, and it represents 230 gigabytes in ZGY data. Now, I haven't copied or read anything at this point. I've just created a virtual implementation of that file. And we'll show that file in Petrel later on. I'm going to add an additional mapping for PaleoScan. PaleoScan requires us to place that in the project directory. And I'll create one more, which will be a subvolume. Now, let's look at the impact here. One thing you'll notice are these additional volumes that have been created for PaleoScan. These are duplicate volumes, but they're indexed in the direction required by the application. The subvolume here represents a smaller volume, and then the ZGY is here as well. So if I look at the total size of all of this data, I've mapped 834 gigabytes of data without needing that data on disk. Opening up that data inside of PaleoScan is simply a case of double-clicking the survey and using the data in exactly the same way that I would if I were reading directly from a file. Scrolling through the data is efficient and fast. And now, showing this in Petrel, I can simply import a ZGY file. This is a virtual ZGY. This data doesn't exist on this workstation, acts as a streaming interface. And simply open the survey inside of Petrel, accept the normal defaults, and just turn on the inlines and the crosslines. And it's very easy to traverse through this data in exactly the same way I would normally do so in Petrel. So the benefits of streaming seismic data from the cloud versus copying it enables you to centralize all of your seismic data inside of OSDU. It eliminates the cost of all of those duplicates for multi-format versions and bringing the data down to workstations and expensive disks. By using transcoding technology, we can represent virtually any format, whether it's SegWy or SEP or other formats can be added. The workflow and the technology is fully backward compatible. The application itself doesn't need to change. And the end user experience is also the same because they're just opening files. And because you're only reading just the data you need, we also see a performance boost versus using the local solid state drive. I'd like to thank our collaboration partners, AWS and Paravida, for this solution.
So let's look at the next solution, and that's from Schlumberger. Schlumberger, one of the partners, also having contributed, of course, to the platform, as we just heard from Rush. We're going to talk about here about enterprise data management solutions. And we're going to look at finding for local data, finding for local applications, and looking at search and other capabilities using the enterprise data management solutions from Schlumberger.
The Schlumberger Enterprise Data Management Solution is an open, ready-to-run, production-grade OSDU data platform and data management toolkit that connects your data seamlessly to your domain applications and your AI platforms. Let's start by creating a project for an area of interest and loading some data into it. Using our enterprise data management agents, we can scan your local file systems to catalog large volumes of content ready to be loaded into the OSDU data platform. In this case, we've identified a number of seismic volumes in original SegWi format that we are going to load into the OSDU data platform. Using the enterprise data management agent's built-in QC tools, we can validate the data before starting the transfer. The data management agent makes it easy to ingest large batches of information to the data platform. You can associate seismic trace volumes easily with their parent surveys, automatically extract the loading parameters by using smart tools to inspect the content, and with a single click initiate the ingestion job. You can also load files directly into the data management application simply by dragging and dropping files from your desktop. The files are published with legal tags to a specific project that ensures the files are available to users with the correct entitlements. Our DataOps Kanban board lets you easily track the progress of your ingestion jobs. Once the data has been loaded, you can use our enterprise data management application to search, browse, and visualize all of the content in your OSDU data platform. Our GIS and table-based browsing tools let you find records in large data collections using faceted search, text, numeric, and spatial filters. The records in this data collection represent standardized wellbores that were enriched from the source format during the ingestion process. We can easily look at the properties of each individual wellbore and seamlessly navigate through to associated content. In this case, log data streaming from the wellbore DMS. Our full text search capability lets us search inside documents that have been ingested into the platform. Our cognitive insights technology applies AI and machine learning techniques to automatically process unstructured content as it enters the system. All documents undergo image processing, text extraction, classification, and feature extraction as part of the loading process. This allows us to produce structured content such as tables and forms from unstructured sources, even if the original files were scans of paper documents. These structured features can easily be consumed by end users in applications such as Excel, where they can be further visualized and processed, or they can be accessed by application developers using our APIs. Data loaded into the enterprise data management solution is enriched and standardized during ingestion, making it ready to stream automatically and seamlessly into end-user applications. The seismic volume that we loaded earlier using the data agent is now registered correctly with the seismic DMS and ready for consumption. The Delphi Petra Technical Suite includes a Petrel data management service to make it easy to access Petrel project data and launch Petrel from your OSDU environment. Inside their Petrel environment, it's easy and fast for the geoscientists to discover and stream the seismic survey directly into their project using the Seismic Explorer tool. Seismic data connected to Petrel using the seismic DMS can offer up to 10 times the performance of seismic data read from local disk. All of the Petrel interpretation algorithms can be run directly against OSDU connected seismic streaming from the DMS, with results liberated back to the platform. This includes our next generation machine learning based automated fault interpretation, which uses in-platform processing to create an interpretation volume registered with the Seismic Data Management Service, ready for consumption by any OSDU-compatible application. The Scalability Enterprise Data Management solution seamlessly connects your people and applications to their data in the OSDU Data Platform.
So now we look at energy with Energy Explorer, and we're going to look at data mining capabilities from well data, all running on an OSDU platform. So it's really around the well data and the various aspects of well data and mining and exploring of data.
Welcome to the future of digital transformation in our energy industry. At Energy, we have created a cloud platform to ingest, catalog, govern, and unleash the power of energy information, aspiring to provide intelligence and timely insights on oil and gas data, from operational data management to economic performance and risks. I would like to take you through 3 aspects of our SaaS platform, using an industry standard approach for data mining public oil and gas well and production data, management of private well data, and comparing privately measured data versus synthetically generated predictions. My first example is on mining for public oil and gas data. We can use our platform to search through public data to go beyond leased lines and discover untapped opportunities. Energy Explorer puts scores of oil and gas production and well data at your fingertips for you to map, view, analyze, and track with clarity and ease. Research that once took hours or days of delving into multiple sources can be performed in minutes with Energy Explorer. Currently, I'm showing the production plotting and auto curve fit regression generated on all production streams within Energy. For most wells, this gives us a head start on determining the economic viability and its future reserves. However, there may be cases from operational influences where the user would want to adjust the auto curve fit, excluding a period of the production stream, or to generate the auto curve from a specific date rather than using the peak production rate. In addition to the auto curve fit Energy generates, users are given the option to manually adjust parameters, tailoring the forecast model for the best fit, and then shared via Energy Vault for any consuming applications like our Energy Explorer or third-party apps who can consume data from an OSDU data platform. My second example shows the use of private well data organized in our platform for operation management of assets. In Energy Pulse, we can quickly filter through the operator's private wells by creating custom sort dimensions to view the operations from various angles. When I drill into the operator's assets to select a well, we can access the wellbore and equipment page. This page shows a wellbore diagram, surface and downhole equipment, completion intervals, and other types of operational history, including drilling and workover entries, well tests, fluid levels, failure and activity logs, and well notes or recommendations for future work. My third and final example illustrates the use of private well data versus synthetically generated data organized in our management platform. We can use Energy to compare actual production in a near real-time basis against reserve plans. Economic and reserve plans are automatically generated for each asset to create the initial model. However, models can be enriched with data streams from third-party economic and reserve forecasting tools, or by creating custom models for manual updates. Energy Vault will securely manage each model for comparison from one to another, regardless of the source. Energy is committed to participating in OSDU's production domain standardization efforts by sharing our domain knowledge and intimacy with Energistics and OPC UA industry standards. We are also committed to actively participating in new energy and CCUS work streams. We have integrated the OSDU Data Platform and services for well and wellbore data and extended domain services in economics and market risk areas, and deployed to Microsoft Azure Blob Storage and Cosmos DB. We are also packaging the deployment of our OSDU solution on IBM Open Data for Industries platform and with AWS Cloud Services. Energy's suite of applications and third-party apps can consume the data with proper authentication to make use of the OSDU partition, entitlement, schema, and storage services. At Energy, we aspire to empower our customers to reimagine energy assets, with digital transformation driving top performance and a carbon-neutral future to help make reliable energy available for all. We look forward to the opportunity to be your partner to realize the value of OSDU and accelerate the delivery of transformational solutions cost-effectively to support your changing needs.
So the what next we're going to look at is Halliburton. Halliburton is we're going to talk a little bit about their commitment both from a data point of view and from an application point of view. And they're going to give examples about the loading of data, look at the quality of the data, and also about the link to DDMS, as you heard earlier from Ras, what DDMS is all about. So that will be the story of Halliburton, and also with a link to their borehole data management plans.
OSDU is delivering a vendor-independent data ecosystem and thereby transforming our industry. Halliburton Landmark is committed to OSDU to deliver tools for managing data, as well as seamlessly operating Decision Space 365 cloud applications on the OSDU platform. Given the sheer volume of E&P data and the need to continuously enhance its quality, the ingestion process into OSDU needs to be high throughput, low latency, and self-cleaning. This enterprise data management can sound like a daunting prospect, but it doesn't have to be. With automated pipelines and intelligent workflows, data quality can be checked, validated, enhanced, and readied for efficient storage and accessed within OSDU, thereby delivering trustworthy data to geoscientists and engineers. Landmark's tools are modular, open, and plug-and-play. Using agile data ops patterns as a foundation, Landmark and AWS have worked together to further enhance the OSDU platform by combining Landmark's deep expertise in E&P and AWS expertise in cloud technologies. These enhancements are being contributed back to the OSDU community. For example, here we demonstrate the preparation and enrichment of log data for ingestion into OSDU. This intelligent automated workflow reduces the need for manual human intervention. The new architectural additions have been contributed to OSDU to support the new binary storage capabilities to enable performant access to the metadata, file data, and high-precision measurement data for log curves. The workflow starts with uploading files using a simple self-service interface. Machine learning is used to predict metadata based on previous results and runs quality checks for completeness, validity, and duplication. This helps ensure that data of good or known quality is available to users in petrotechnical applications, including AI ML models. Once prepared, the data is ready to be submitted into OSDU as a system of record. A manifest is created with the enriched metadata, QC metrics, and original last DList files, as well as the extracted log curve measurement data. So now we have quality data prepared and ready to go, we need to start putting that data to work. Data can either be ingested directly into OSDU or can be registered from external systems. By dynamically registering data from EDM and OpenWorks, users can continue working with the applications they know and love, like Digital Well Program, a Decision Space 365 cloud application, as well as simultaneously integrating with third-party applications for end-to-end workflows. With a rich set of data available in OSDU, we can start utilizing that data to create new value-adding capabilities. One such example is ROP prediction and drilling optimization in real-time well engineering, another Decision Space 365 cloud application, which takes the cleansed log data and drilling parameters. Here you can see data being queried via the OSDU search APIs for binary data, as well as the drilling data via Jupyter Notebook to experiment and build a new AI ML model. We'll start with querying the OSDU master records to retrieve the well and wellbore that were used in the previous two demonstrations. After selecting the wellbore, we query for the associated registered targets. With the retrieved data, we are ready to utilize delivery APIs to retrieve the URL and query for the full data to ensure we are getting the most accurate, updated data. Now that we have our targets, we want to query for the newly ingested log curves for the same wellbore to correlate the data. With the new binary storage and API, we're able to quickly visualize the log curves in our Jupyter Notebook to build the models. Models that are built on Jupyter are now running on Geoscience Suite, a Decision Space 365 cloud solution, and this new data can be used for automated well correlation and assisted lithology interpretation. Landmark, along with its partners like AWS, are excited by the potential of future releases and new capabilities which we will collaborate on and deliver to the industry. Together, we're committed to partnering with our energy customers to understand their challenges with subsurface data and support them to fuel sustainable innovation. Since 2019, Landmark's cloud-native microservices and workflows have been and continue to be OSDU compliant. We have made an OSDU instance available publicly in our Open Earth community and created an OSDU reference implementation, which we continue to optimize for performance and scale, and contribute changes and enhancements back to OSDU. Decision Space 365 cloud applications run on OSDU, and the workflows you have seen today are just a glimpse of a much more comprehensive solution for borehole, seismic, drilling, and subsurface data that will help enable you to transition your data and applications on top of this OSDU release while enabling business continuity for your users. To learn more about how you can use Landmark solutions in AWS to enhance and accelerate value of OSDU, contact us here.
Very good. We go to the next one, SoftServe. SoftServe is going to talk about well logging processing and the use of AI, all based on top of OSDU. So OSDU has the Azure Data Platform, and then really well data related activities. So we're going to hand over now to SoftServe.
Hi. In the next couple of minutes, we will guide you through SoftServe's solution for well logging data processing and lithophase prediction. It's built upon the OSDU platform and it uses emerging technologies like artificial intelligence to help reduce human efforts, automate and optimize workflows during well logging data conditioning and interpretation.
This application was built with OSDU in mind. It expects to work with data using OSDU services, and it expects to be a part of workflows inside OSDU. We support both being the point of entry and being just a part of the workflows for the data that's already in the system. In case our application is a point of entry, both original and resulting files will be ingested and registered, making them searchable and allowing you to use them down the line in your workflows. Application is exposing a REST API for usage as a step of a workflow, and UI is available to explore the processing results. Metadata, along with additional resulting files, is also saved to cloud. However, the exact configuration of files that are going to be usable by your workflows in future is defining what will be stored, not to bloat storage with some views that you are not planning to leverage. For the sake of demo, we are just going to use a few pre-uploaded examples. Architecture-wise, we are running two ECS tasks using Fargate. One of them is good at magic with the data itself. Other one is taking care of OSDU integration and is good at communicating with the world. We also use DynamoDB and S3 for the sake of caching some of the results for midterm, but their usage heavily depends on your configuration and can be avoided at all.
Here you could see a conceptual diagram for well log processing and lithophase prediction application. It consists of 6 components. First start with reading class file, then we do parsing of headers by retrieving coordinate information and detecting correct well names. We run mnemonic group prediction model, which identifies mnemonic group based on dictionary or based on classifier. We run data preprocessing by clipping mnemonics and standardizing units. There is data enrichment component, which is responsible for removing hang values, filling gaps within the mnemonics, and selecting best curve within each of the identified groups. And on the last step, we run lithology prediction model, which assigns lithology for each of the depth range.
In this screen, you see well logs processing. And first in the table, you see the results of mnemonics grouping, mnemonics units detection, and standardized units creation. So we first detect the mnemonic name, as you see it on the left. Then we use variety of methods like dictionaries and ML algorithms to detect in which group the mnemonic is. So for example, in this predicted group, we define that mnemonic CILD is a resistivity mnemonic. So we assign it with the resistivity group. Next, we use different approaches to detect units and then convert them to normalized units that will be further used for lithology prediction. As you see here, it's not always only about how units are spelled, but often, for example, with NFI, the mnemonic NPLS, it was first stated in percents, but our further processing and model use decimal units. So we have converted it to the decimal from percent. You see on the screen that the first original output were done in percents, and the standardized and normalized, and then is created in decimal units. Clipping is used to cut all of the unuseful information in a mnemonic. As you see here, the values above 650 were clipped as they are not used for further lithology interpretation. Now on the screen, you can see the results of lithofaces prediction. As of now, model is trained to distinguish between 12 rock types. For further solution enhancement, additional rock types can be added by adding the data to training data set. As you can see, model is able to predict both massive formation and very thin interlaminated beds. Let us talk about how we can help you dramatically increase your efficiency with the well logs. At SoftCert, we have a global team applying AI and ML, big data, and DevOps expertise to solving the biggest challenges facing the oil and gas industry while partnering with the most trusted cloud providers in the world.
So next we're going to talk about Icon Science. In Icon Science, we're going to talk about, you have 3 products, but we're going to mainly talk about the Curate, which is the latest knowledge-based product. Is being used by both science engineers to access the data. We also will talk about 2 other products, iPoint and RockDoc, but really the focus will be at Curate. So we're now going to hand over to Icon Science for their presentation.
Hello everyone, and welcome to this demonstration from Icon Science that shows the seamless integration between the OSDU and our next generation knowledge management system, Curate. Icon Science joined OSDU in 2019 and are proactive in the community. We provide domain specialized knowledge across multiple subsurface disciplines. Specifically, these disciplines focus on population, data identification, reformatting, metadata extraction and integration as typified by our iPoint software, and utilization. For example, identification of the highest value data and building value-add workflows, and our RockDoc software is a powerful example of that. Curate is Icon's brand new web-native software for generating and disseminating knowledge. It allows us to focus and direct both data and knowledge so that it gets to the people who need it when they need it. With Curate, we bring the data and the knowledge to the workflows. Therefore, integration with the OSDU is of utmost importance to the system and to our wider vision for knowledge management. I will now show a demonstration of Curate and show the integration with the OSDU in action. This is the Curate login page, accessed through any web browser. I click Login and I can use single sign-on or SSO to access the system. Once logged in, we arrive at the Curate collaborative workspace, and here I'm presented with all the well and seismic data I have loaded into the system. Wells from the OSDU are indicated with the blue diamonds. Wells in the system from other sources are indicated with green circles. I can also stream in third-party overlay data, such as accumulations and block boundaries. I'm interested in a study area in this example, which is between the wells from the OSDU to the north and those from other sources in the south. If I want to review the wells that are available from OSDU, I can go to the OSDU tab and the wells are listed. I can easily search through these wells using the search box. At this stage, I can define a project based on a selection of data. So I select the wells of interest in the study area and create a project. This includes those wells from the OSDU, and I can select those just as I would any other wells. The wells can be added or removed from projects individually, from the tree, or by using the lasso tool. Once a project is set up, I can add other people in order to work in a collaborative manner, view the same data and displays, and work simultaneously. I've already set up a project here, and this can be accessed from the projects menu. I may wish to start by understanding what data is available to me in each of the wells, what data types, the coverage of the logs, and also what documents are associated with the wells, so I can very quickly assess the data associated with the wells that I have available. I then would like to view the data I have in the system, so I can turn to our suite of web-native applications to do this. The Well Viewer is an easy-to-use viewer for well data, so here I can select one of the wells from the OSDU, drag and drop logs into the display, and easily adjust display parameters such as colour fills and track scales. I can save sessions, and these sessions can be viewed by all collaborators at the same time. Here's a session I saved previously to show the type of display that can be defined. Templates allow the views to be propagated across all wells in the project. In this case, I have various log fills, cross plots and track dependent scaling where the depths are linked to the red marker. So a great demonstration of having OSDU data available and very rapidly being able to visualize that data in a collaborative manner. There are other apps I can make use of. So for example, here I'm showing a correlation line between the wells. And here I'm using our AVO app to perform fluid substitution and AVO modelling. Our full-featured software packages, RockDoc and iPoint, also exist within the Curate system, and these are therefore able to make use of the OSDU integration. So in summary, Icon Science are proactive contributors to the OSDU community. We provide domain-specific knowledge for data population and utilization. We provide seamless integration between the OSDU and our products as part of the Curate software system. Curate is web-native software for generating and disseminating knowledge. That concludes the demonstration. Thank you for listening.
And last but not least, we're going to listen to Anthord. Anthord is going to talk about their subsurface AI seismic application, which really runs on top of OSDU and is really meant for pattern interpretation, pattern recognition using the AI technology, train your models, prediction, etc., all based around this AI capability running on top of OSDU. So we're going to hand over now to Anthord.
Subsurface AI Seismic is a cloud-native web application that allows users to train and use AI to accelerate interpretive tasks. With the OSDU platform, it becomes possible for inventors, such as Anthord, to create and distribute best-in-breed cloud-based applications, targeting specific steps of the larger exploration workflow. The OSDU platform allows us to create an application that gives users consistent, secure access to their data. Data ingested into the OSDU platform is made discoverable through search and consumed efficiently with technologies such as OpenVDS for seismic. Standardized schemas, seismic horizons and seismic fault planes allows us to publish results in a generic way. And now, let's have a look at subsurface AI seismic in action.
What do geoscientists see when they look at a seismic line? Do they see seismic wavelets? No, they see patterns. Patterns that tell a story about the prospect, the reservoir, the source, the seal, or the trap. Seismic facies, onlaps, downlaps, truncations, strong amplitudes, and weak amplitudes. These all give clues about the rocks or sediment behind the data, and when woven together, they tell a story about the geology that our minds can interpret due to visual patterns in the seismic. Existing seismic interpretation tools and software, however, don't allow the interpreter to work directly with patterns, and thus, they don't work the way our minds do. So we built Subsurface AI Seismic. Subsurface AI Seismic allows the interpreter to use the power of artificial intelligence to interpret horizons, sequences, faults, seismic facies, and geobodies using pattern recognition. During the interpretation process, the user trains the AI in the way they want the interpretation to be done. Unlike conventional methods, the utility of the AI improves with feedback from the user, and the amount of interpreted data available for training the AI grows. Subsurface AI Seismic is a cloud-native application with a web front-end and is aligned with OSDU guidelines. With Subsurface AI Seismic, the geoscientist can access tools in an interface that will make any seismic interpreter feel immediately at home. Using Subsurface AI Seismic, the interpreter can collaborate dynamically with other team members, sharing interpretations and commenting on each other's work. The application is built to be intuitive and simple to use, enabling the interpreter to rapidly build training data, which the AI can then use to make predictions on nearby lines. The work is a collaboration between interpreter and AI. The interpreter trains the AI and QCs the predictions. While the AI learns from the interpreter and progressively improves. With the help of the AI, tasks that used to take weeks or months can now be done in minutes. Efficiently interpret your seismic data. Collaborate with your team. Build large volumes of machine learning-ready training data. Leverage AI to help your asset teams make faster, better decisions with Subsurface AI Seismic. From InThought.
Okay, we go to our next session. And now we're going to look at Jort from Rush, really what is the Mercury all about. This has been launched today. And now we're going to look at, okay, what are our plans for the foreseeable future? And I'll try to do it in about 10 minutes because we still want to make sure we have got some time left for Q&A today. So we're going to talk about upcoming activities. And this is not far future. It's really, we're talking things where we've started, but you all think post the R3 Mercury release. What this is all about is really our overall strategy is to make the OSDU the open energy data platform for any energy source. You bring the data from any energy source, whether it's oil or gas, whether it is wind or solar, whether it's CCUS, whether it's geothermal, you name it, into a single data platform. And why is that important? It's very important because if you have that mixed, because increasingly we have a mix of many energy sources. And with that mix of energy, so we have to come to the most optimal proposal for energy provisioning. And that is ideal when you have the data from the various energy sources in a single data platform. So your AI applications can make use of all these various data sources into a single environment and can make the best forecasting for the optimum mix, depending on your constraints, whatever you have for the next so many hours or so many days. So that's one example what is very useful for good for forecasting. So therefore our strategy, and for other reasons, is really making OSDU an open energy data platform for all energy sources and related data. And related data could also be your greenhouse gases information, etc. And we'll talk about that in a moment. This is our overall strategy, what we're heading for. This is the underpinning picture. The blue and the red part is really the OSDU data platform. So the blue part is really on the left, what we've launched today, exploration, development and wells as part of the OSDU data platform on March 24th. And then we've got an active project looking at drilling, we've got an active project looking at adding production, upstream production to scope. And once we have that, we have an integrated upstream business, because we have everything from exploration, development, wells, and production into a single data platform. And that's we target that for the second half of this year. And we're adding, and we've got active project on that one as well, solar, wind, CCUS, etc. And we've got an active wind farm program going on and an active CCUS program going on. All of that data comes together into a single data platform called OSDU and accessible via a single set of APIs. And of course, for a number of them, and you heard from Russ, we will use DDMS solutions. And we introduce more DDMS solutions over time where that makes sense. And on top of that, you have your business applications. I gave many different colors because they can come from many different suppliers. That's where people want to compete. That's where they want to see things happening. On the left, you see it's open source. You heard from Russ, it's an open source based environment and it's real time. It's a near real time environment. We're also driving things like Kafka into the platform. So we're really creating here a platform ready for increasing real time environment, because increasingly our data sources will come in a near real time fashion from many different sensors out there. So stepwise, we're adding support for extra energy sources. I gave you some examples of that, and that work is happening now. I mean, we start these projects have been kicked off. I mentioned wind farm, CCS has been kicked off and is working with the members. Real-time support, important for almost every energy source, even for our traditional energy sources. Open source, important to make sure, based on the Mercury platform we have today, that we can give support for all these various energy sources. And you heard from Russ how we're going to do that. And also, we've also added, and we're also developing a project to come to an open source based edge solution. Because increasingly, for a number of environments like production and in new energy source, we need an edge solution. So we want to have an edge solution which is also open source based, well integrated with the OSDU data platform. And the marketplace. And today, the marketplace where people can bring their applications, the marketplace from Microsoft, from Amazon, from IBM, from Google, they all have their marketplace, and that's where we want people to bring their applications to make it very easy, a very low threshold to get your applications into an OSDU environment. We also have a project together with the IGP. And with the IGP, we're looking at, can we also integrate, and IGP stands for the International Association of Oil and Gas Producers, where we're working with them to really bring also the engineering data. So your piping, your instrumentation, your electrical, your 3D engineering models into the OSDU data platform. Then we have in the OSDU data platform both your engineering data and also the operational data. That means I can create a digital twin, because a digital twin is really bringing together my operational data sources and my engineering data sources and overlay them, so that you see your production data and your engineering data into a single view. And that's really what we're after with the OSDU data platform, and adding to that also the engineering work. This work had started about 2 months ago between a group at OSDU Forum and a group in the IOGP. That's the first point being covered over here. Also, I want to remind again that the bullet point 2 here. OSDU is a system of record. Russ was talking about it in his second slide. It's not a data warehouse. It's really where you store your data. So when people talk about, I have lots of legacy data in many different environments, over time, you take that data, you move that data, you don't copy, you move that data to the OSDU data platform, and you can remove your legacy data sources. So it's very important that that's the world we move into, and it's a system of record. That means we are not deleting data, we're adding new versions to it. So the whole design has been taken into account. And the third bullet point, we spoke about the various new energy sources, but also think about your greenhouse gases, your CO2, your carbon emissions. Think about your ESGs, your economic, your social and so environmental, social, and governance data. Also, that becomes data which will start over time storing in an OSDU data platform, because it becomes very closely related with your energy sources. So all these things do come together. And why is it important? So you can do better predictions. Yeah? You can do better forecasting for the future. Because if you look at the whole energy market, the market will be, because it's digital, will be driven by data. Who has access to all the data? Who has all the data, both your own data, external data? Yeah? Who has the best AI models out there? Who has all the data available to those AI models? Who can best predict the future need for his own energy sources? Yeah, because the best way you can predict the future need, the best margins you can make. If you predict wrongly, it always will impact your own bottom line end of the day. And also the speed of it. If you're faster than your neighbor in your trading space, again, it's important. So it's all about a data platform, a real-time data platform with own data, third-party data coming together into your AI space. This is an example of what we do in the case of wind farms. We have an active program with about 20-25 members out there, and with really trying how do we integrate wind turbines, wind farms is an offshore environment, into an OSDU environment. Well, of course, you collect there very different data types. Of course, you have some different standards out there, like the IEC 61400, which are standards being used in this world out there. So we need to include those standards into our OSDU data platform. And last, think about, if we talk about the OSDU data platform now and for the future, it's really ready for the future. It's API driven. The API derives and separates the data from the applications. And you heard about the two types of APIs, which Russ was talking about. It's open source, means it gives us maximum flexibility. It's us, the members, and everybody else who's involved in open source software can drive the new capabilities. It's not one or two suppliers, it's all of us. The forum drives the standards for the data platform. So not one supplier, no, the forum, all of us drive these standards. So we have maximum flexibility, maximum accessibility to any supplier to that forum out, to that data platform out there. And it's about new energy sources. Vitally important that we go with the market, that we really bring all these energy sources together into a single data platform so you can make maximum use of that data out there. That's really what I want to talk to you about from a future point of view. The future is very exciting, lots of opportunities, and we didn't even talk about all the opportunities out, because there are a lot more opportunities than we even spoke about now here today. I'm going to hand over back to John for our Q&A. Mr. John.
Thank you, Johan. Philip, I'd like to invite you and Raj to come back on microphone, and there have been a lot of questions coming in from the very beginning, so we'll deal with as many as we can in the time given, and those that we aren't able to cover, I know some of them have already been covered in the Q&A chat, but if there are any at the end that we haven't covered, we will take those questions back and we will answer them independently after the event, but we'll try and cover as many as we can. So from the top here, this is from somebody who's obviously got a bit of a knowledge of various space missions. The first question is, how and why did the Open Group choose Mercury as the brand for the launch of the OSDU release? And will there be a second generation Gemini or Apollo launch?
I think this is a plenary thing, right? Because we are a universe, so we picked the name of a star as the first release. In the future, if we have a API change and create a new version, of course, we may have other releases, but mostly that we would generate continuous releases.
So why the name Mercury, Philip?
Mercury, I think, Johan, do you want to comment on why we picked Mercury?
No, we had a number of choice points, and it was done by the communication team. I wasn't directly involved in it. Why the name Mercury came, if you really want to know, we can find out, because it was done about 6 months ago. But I can't exactly say why the name Mercury. I can't say. If it's an important question, we can find out.
Yeah, somebody in the Q&A said, why not Mercury? So I guess one name's as good as another. Okay. So there's a question here. Please inform the rough timing of the post R3 training schedule and also any note about the online training.
Yeah, let's talk about the training schedule. The training we're developing, which we refer to, is really training about the data platform. So we're developing, as a start, 5 training modules. One, for instance, one about the data platform itself, one about operational procedures. These are 1-hour modules. These are being developed starting mid-April, because we first had to make sure we had material available to start doing the training. They will release immediately when they are available. So they become available, I would say, early May onwards in over a couple of weeks, and it will be, as I mentioned, 1 hour each. We're also looking at, so this is really about the data platform. We're also looking at whether we need to restart our application development as well. And we have a session about it next week in the OMC to see what we're going to do in the space of application development. Because we had in the past supplied by EPAM also training for application developers. And we really think we should restart it again. But we will come out to all the members, I would say the next week or so, to see what's the interest over there. If there is sufficient interest, we'll help to enable that to happen.
Also, don't wait for the training classes. Go to OSDUforum.org. There are lots of documentation, like reference architecture, data schema. Those information will be useful for all of you.
Yeah, thank you.
Okay. This question, I understand that the OSDU standard is only available to member organizations. Is there any way individuals between jobs can have access or contribute to the standard?
I think when the standards are published, it published to the public.
Yep.
Only when the standard being worked and is only visible to the members.
Yeah, and outside the standards, a lot of other documentation. If you go to the OSDUforum.org and the first page is R3, and you say R3 more learning, you find almost all documentation there as well.
Okay. The other side of the question is that currently the member is a company membership. Currently, the Open Group does not support individual membership, but there is an exception. And if individual is a technical expert in certain area, that we can invite individual as invited expert for a limited amount of time.
Okay, thank you, Philip. Okay, are there any US Federal Trade Commission or European Union barriers to accelerating the OSDU standards implementation?
Rush, I think about that. Rush?
No, I don't think so, Johan. I mean, the software is licensed under Apache 2. There were a few situations, like, for example, Elastic, where the license had changed.
Yep.
But we take proactive measures to work with those dependencies and make sure that the software that we deliver is either Apache 2.0 for things that we write, or is compatible with Apache 2.0, so you don't have an issue for adoption.
Yeah, exactly.
Okay. Okay, what are the top 3 key gaps in open source standards for upstream, midstream, downstream, and chemicals in the energy industry in 2021? I know that's a massively broad question, but anybody want to try and answer some of that?
I'll take the first crack. In terms of upstream, we need to define additional data type in a subsurface area. There are lots of data types still need to be defined. In the production area, we need to start defining the standard for real-time data streaming. How can we bring real-time data into the platform? Also, we need to work on the standard on the interface between OSDU Edge and the OSDU Data Platform. And on the application area, and we can working on the standard workflow orchestration standard as at application layer. Okay, Raj and Johan, you can add.
I don't know whether that was the question, because now you gave on the holes in OSDU over the option. I thought it was more a general question about open source.
Yeah, I addressed the OSDU gap.
Yeah. I mean, I'm not much to add. I mean, yeah.
No, it was quite a general open source question, to be honest.
Yeah.
So I think I wouldn't say it's a gap, but where we are doing the work is really in terms of stitching the horizontal open source projects to fit these different domains, right? So, at the end of the day, you also see it in the chat. People are asking about Airflow or Kafka or Cassandra or whatnot. So there are technologies that are available to help us, whether this is on the messaging front for real time, or whether this is document storage, graph storage for relationship and tracking in the modeling and the upstream space. But what we don't have is a platform that is really targeted towards energy, right? So that's really the mission. That's really the gap. That's what we're working on.
Yeah.
Thanks, Raj. Okay. Are there any specific OSDU requirements or recommendations for documents that are associated with ingested data? Most likely that information will remain in external closed document stores and run the risk of being disassociated. Does the OSDU handle documents at a foundational level today?
Yeah, there's two approaches that we can take, right? So what you will find with the manifest-based ingestion is, and this is if you want to go down that road, is you can actually securely upload those documents to be with the data in the OSDU platform. And the manifest will describe the file or the data set that you are bringing in and associate it with other domain entities. The other option, it's not something that we do out of the box, but the schema service lets you to do that, is you could choose to have, assuming that you have a durable URL to where the document is persisted properly, is to not have the actual contents uploaded, but you still put a manifest and you put in a URI reference to where you have the document held durably.
Okay. Right. Can you share the OSDU schema for engineering data?
Johan covered that. We collaborate with IOGP on the schema for engineering data. Yeah.
Yeah. There's no limitation in the platform that you cannot do it, but you have to add the right data types for that, of course. There's no limitation in the platform that you cannot do this.
Okay, moving on. Are there now two competing seismic data formats at the core of OSDU, ZGY and VDS?
I wouldn't say that as a competing data format. There are both formats are supported by data platform, and application would access them through DDMS API.
Yeah, okay, that's a good point there, Philip. At the end of the day, there is investments that people have made in ZGY and VDS today. What this does is it opens up those formats in an open source space. But in terms of a platform, the management and the serving of the content is all merged together under one seismic DMS.
Yep.
Okay. Right. What's the scope of the OSDU data model? Do you support the top side and the midstream side? For example, I'd like to ingest inspection data that would consist of photos and video files. Can this type of data be supported now or in the future?
In theory, they can be supported. We just need to collaborate, define the schema for those data type.
And we have to do some work around it, but it's again, it's same as engineering data. All this data, we have to do some work happen. So if you say, can you do a bit out of the box? No, we have to do some work to make it happen. But it's really the data type story we're talking about.
Okay, moving on to some of the questions that came in during the demo video. So I'm not sure if you're actually going to be able to answer these, but I'll put them anyway. So the initial one, so there was a question coming in saying, what are operators discussing as priority of use cases? Examples? Does anybody have an answer?
I don't think we should answer questions from the demos, because then we should go back to the companies themselves.
Right. I know that Raj did answer a couple as they were happening, so that was helpful.
Yeah.
Okay. Right, here's one that came in afterwards. Are there any intellectual property barriers in implementing the OSDU platform?
I think we just covered that a moment ago, Russ.
Yeah, that is correct.
Yeah.
Okay.
I think the export control issue has been dealt with.
Correct. So
Yeah.
we have a ECN classification as well.
Yeah.
Right. How can an organization evaluate and experiment with the OSDU data platform? Can the platform be run on a local laptop environment? Are you providing cloud formation / ARM templates for cloud deployments?
So if you're working with a cloud provider, I believe ARM is Azure Resource Manager templates, then yes, the templates are available. So if you go to the community GitLab, you will find the deployment templates there. If you wanted to deploy it on-prem, then there are a couple of solutions available. So for example, the IBM solution doesn't require a public cloud infrastructure. So you could certainly go with that. The public cloud providers are also looking at options for in-country. So you may want to reach out to them for updates on that one as well.
Yeah, and there was you also look at one of the demos this morning from 47 Lining. It gives you also opportunities for low-cost entry into an OSDU type environment. So look at the recording of the demo this morning.
Right. Also, there are companies that will offer a SaaS application of OSDU, so you can even use the SaaS model. So check with the catalog to find interesting offering.
And you can expect more announcements in the very near future from other companies who will have other scenarios available as well.
Okay. A couple questions relating to oil and gas companies. How long will it take oil companies to move from their existing data platforms to the OSDU platform? I guess that's how long is a piece of string.
How long is a piece of string? What you really have to avoid in an incremental fashion, because we had the discussion also this morning. Oh no, sorry, I had the discussion yesterday. You really start looking at what are the workflows you want to move. Yeah, okay, and then say what are the applications and what's the data go with it, and then in incremental fashion start moving that data. Of course, you will always be in the time where some of the data will be on premise, some of the data will be in OSDU. But you're not going to spend years on data loading. You really do it incremental, get benefit from the data you've moved, from the application you've moved. Take the next step, take the next step, take the next step. But Rush or Philip, maybe other input as well.
Yeah. Change management is massive because we are implement a transformation here. So expect to have a transition period. That's why the technology like fast technology like SSIO are very helpful during the transition period, where you can deliver the data from OSDU data platform to your application on-prem.
Okay, and the other one, sort of slightly related. How can the OSDU Forum guide the non-member oil and gas companies to adopt and leverage OSDU platform and its benefit? I guess the answer there is to join the OSDU, but any comments?
Yeah, well, if even you don't remember, they have access to the outcome. They can go. Everybody can go to the cloud providers and say, "Please install in my environment," whether you're a member or not. So you all can benefit from the results. If you want to influence the result, of course, then become a member. But if you say, "I don't want to influence, but I do want to benefit from it," you can do that. Everybody, whether a member or not, has access to the outcome of what you're delivering. So everybody can go to Microsoft, to Amazon, to Google, to IBM, say, "Please install OSDU on my subscription."
Okay, thank you. I think that's pretty much it, guys. I think a couple more questions might have come in, but we'll call it a day there. So, Philip, I'll hand back to you for some closing comments.
Okay, thank you, John. As I said in the beginning, that the Mercury release is the beginning, and this release allows us to scale up our collaboration in a big way. So I really look forward to working with all of you in the coming months to explore the opportunities for further collaborations. I would like to thank the Open Group for hosting and supporting this event. Many thanks to the keynote speaker and the presenter, including the video presenters. A special thank to all those who contribute to the code base in the past 10 months. Also, we can't do this without the OSDU focal points, OMC members, PMC members, and members of our technical subcommittees. I'd like to thank you all for joining this launch event and hope you have a safe, a peaceful day. Thank you. Bye-bye.
Thank you, Philip. I know there have been a couple of questions coming in relating to the video and the recording here. This session has been recorded. The earlier session we had a number of hours ago was also recorded with the different demo videos in it. Both those recordings will go through a post-production process and they will be available within a few working days. Everybody who attended this session or the previous session will be informed how to access the videos for either of those sessions post-event. And I believe the slide decks are also going to be posted on the OSDU member site. So thank you all for attending. Philip did mention there are a lot of people who are involved behind the scenes with this, and we're going to finish with a brief video, which is basically showing some of the folk who haven't appeared today, but who've been busy working on the platform release. So thank you all for attending, and we will close the session following this video. Thank you.